All right, starting with question number 7. And I guess let me put up here, these are the angle conversions, and this is an example. It starts with question number 7 because we already did part 1 of this exploration. So starting with question number 7. When the part that we should be able to do first and quick is naming the equation just based on what it's given, and naming it and sketching a graph. And so, can anybody tell me what this is the graph of? A circle. What's the radius? How do you know? Yeah, so the 4 is actually r squared, not r. So, yep, it's going to be a circle. And the radius is 2. Where's his center? Yeah, 0, 0. So if I was going to make myself a little sketch for this, we've got the center at 0, 0. And then we have a radius of 2. And so we have a little sketch. It looks like this. And it's going to look the same whether it's a rectangular graph or a polar graph. It's still going to look like a circle with the center at the origin and a radius of 2. As a polar equations are r equals. Y'all should be able to tell me without conversions, what is the equation of a circle centered at the origin with a radius of 2 as a polar equation? What is it? R equals 2. Yeah, we already know that it's r equals 2. But just using conversions, x squared plus y squared is r squared. And so if we have r squared is equal to 4, we can take the square root of 4. And so we get r is equal to 2. And what you'll find is, by and large, the ones that I've noticed that you get assigned are all things like circles or lines. And converting circles or lines, you're going to start seeing a lot of patterns, converting from rectangular to polar. And if you don't recognize the patterns or you don't start memorizing them, then you can always use the backup plan, which is conversions. So this would be using a conversion. But again, if you looked at this and you were like, that's a circle with a radius of 2, the equation is r equals 2, like I can see why you could get to that point. Next 2 graphs. What's this the graph of? Okay, horizontal or vertical? This one is vertical. Nope. A horizontal line because it goes through the y-axis. And then the x equals equations, those are vertical because they chop through the x-axis. So those are easy to get confused. So yep, if I sketched out what I think that those are. And so I'd like for y'all to take a moment, make the sketch. These two questions in particular help you with the quiz. So I'm going to show you exactly what I want your quiz question to look like. It says that I want to see steps, and it says no fractions as your answer. So I'm going to show you exactly what you should be having for your quiz. So this is a y equals equation, and looking at our equation conversions, if I know y, then I know that y is equal to r sine theta. So I'm going to replace that. I'm going to replace y with r sine theta equals 4. Some people left, I don't have a lot of people that have taken the quiz, but some people left their answer like this, and this is not a polar equation. Polar equations are r equals. That's what I mean, yes, this is a polar equation, but I want to see your final answer as r equals. Kind of like if you wrote a rectangular equation, a lot of times it's y equals, except for a circle or like conic sections. So this one, we want to get r equals. And so to do that, I'm going to bring over the sign. So I'm going to bring over the sign, divide by sine theta. However, I just made a fraction, and the quiz directions say don't leave a fraction. So this is the same thing as 4 times 1 over sine. You don't have to write this. You can just follow along. What is 1 over sine? It's a reciprocal identity. What is it? Cosecant. Very good. So we get 4 cosecant theta. So when you see cosecant, r equals a number cosecant, that's going to always create a horizontal line because cosecant goes with y, which goes with sine. And it's going to be wherever that value lives. If it was -4, it would be down here. And again, you'll start seeing the pattern to where you don't have to write out all the steps. However, for your quiz, that is what I want to see. I want to see that your first step is r sine theta equals 4. Then I want to see that your next step is r equals, so the step I want to see in between, r equals 4 over sine theta. So I want to see this in blue, this in blue, this in blue. Obviously, you can't show that quite as easy. So you show it like this. So this is how we would show these steps. We're going to do the same thing with x is equal to 10. So I'm going to do it quietly up on the board. You do it on your paper. It's the same steps. How'd y'all do with question number 9? Do you agree? Yay. All right, we've got a couple more. So this is an r equals equation. That means it's polar, and we want to go to rectangular. So for this one, what is this? What is this equation? What does r equals 3 create? What does r equals 3 create? The graph of circle. What's the center? And what's the radius? Yep. Circle, radius equals 3. Center is the origin. Very good. We've got the center. 1, 2, 3. 1, 2, 3. 1, 2, 3. We're going to pretend like I made a beautiful circle. And so having the idea or a good foundation of what these graphs look like, it makes the equation conversions much easier because you kind of know what it's going to look like. I know that circles are x squared plus y squared equals r squared. It's going to follow that type of pattern. And since this has the center at 0, 0, it doesn't have any x or y movement. It makes it even easier. So first thing I'm going to do is replace r. Sorry, I'm going to change that to where I have r equals, sorry, I have to have r squared. Squared, I got to square both sides. So I get r squared equals 3 squared, which is 9. And I know that r squared, using our our equation conversion, r squared is the same thing as x squared plus y squared. So I'm going to change it to x squared plus y squared equals 9. And that is my rectangular equation. So I can use conversions, or I can recognize that it's going to be in this form. So I've just got to square the radius. Any questions over making the equation of a circle centered at the origin? Okay, the next two are super easy. This is going the other direction. So tell me, what's this going to be the equation or the graph of? R equals secant is going to be the graph of what? It's going to be the graph of a vertical line. So this one, it's not an R equals equation, but if I divided by sine, I would have R equals, and divide by sine is the same thing as cosecant. So this is going to be the graph of what? Mm-hmm. Yeah, this is also going to be the graph of a line. This one is going to be vertical. Secant goes with x, so it chops through the x-axis. Sine goes with y, and chopping through the y-axis will create a horizontal line. So I'm going to name the graph, I'm going to sketch it, and I'm going to use equation conversions to convert it. So you should do that on your paper. All of them. The homework is all of them. Because we're going to do the most of the odds together. And there's only 12 questions. Yes. Oops. They did you a super favor with question number 11 because they had it already set up. R sine theta is y. And so you just replace that with question number 12. Oh, why do I have them backwards for numbering? That's weird. Oops. In any case, here you have to divide by secant. 1 over secant is the same thing as cosine. So you can replace r cosine theta with x. So using angle conversion, equation conversions, you can convert both of these equations. Any questions so far with what we're doing? Y'all feeling all right with it? And again, the good thing is that the equation conversions are exactly the same as the coordinate conversions. And so you don't have to memorize 2 sets of conversions. So they're the same. We're going to move on and we're going to do some questions from the homework together. And I have question 1, 3, and 9 that you can do by yourself. But first, I would like to do question 5. I'll do question 5 and question 7, and then you can do these on your own. And I'm assigning all of them, and you should be able to do them without a calculator. Like you don't need a calculator for these. So question number 5 is a little different. If it was x squared plus y squared equals 4, then I know that that equation would be r equals 2. It's a circle with a radius of like this one. This one's really easy. Like you don't need a whole lot to be able to convert this one or write the equation of your polar equation here. But here you need to do a little bit more. So for this one, this is like the example on this paper. In fact, it's just like the example on the supplemental paper that we just did. So if you want to have that right next to your paper while we go through question number 5, it's the same type of steps. So the first thing that we're going to do is bring all the x's and y's to the same side. So we're going to bring over and subtract 4y to the other side. So we get x squared plus y squared minus 4y equals 0. And then from here, I'm going to do some conversions. I know that x squared plus y squared equals what? R squared. And then I know that y equals r, I was about to put sine theta. So I'm going to rewrite this. So I get r squared minus 4r sine theta equals 0. And then I notice that both terms have an r, so I'm going to factor out an r. Factoring is the same thing as dividing, so I'm going to factor out an r. It's going to go out into the front, and I'm left with r minus 4 sine theta equals 0. And then from here, I've got 2 terms that are being multiplied and they're equal to 0, so I can split them and set them both equal to 0. What do I get when I put r equal to 0? Nothing. So out this side, r equals 0. That doesn't produce anything. So out the other side, I'm going to have r minus 4 sine theta equals 0. And so I already know that I'm going to have to bring that to the other side. So I can go ahead and rewrite it like that. So I get r is equal to positive 4 sine theta as my answer. Are we good with this one? So I went over the example with you and then we just did one together. So I'm feeling like that you can do question number 6 from the homework just fine. You have a guide. And then I'm going to do question 7 with you, and question 11. You can see that it's pretty much the same. It's just a different value, but you're going to solve it the same. So question number 7, to solve this one, This is kind of working backwards because this is a polar equation that we're going to Cartesian or rectangular. And so with this one, you know how once we got to the end, we eliminated the r equals 0. So like we had an extra r and we got rid of it. Here, I need an extra r to solve this problem because I don't know what sine equals. I know what r sine theta equals, and I know what r squared equals, but I don't know what just r equals. And so with this type of equation, I have to introduce an r. So it's the opposite, like here where we took the r out, we're going to introduce an r. So I'm going to multiply both sides of the equation by r. So I'm going to multiply this side by r and then this side by r. So now when I rewrite it, I end up with r squared equals 3. And if I put the r in front here, because you can multiply in any order that you want to, now I have things that I can convert. I know what r squared is, and I know what r sine theta is. So now I have things that I can rewrite. I know that r squared is x squared plus y squared. And then I know that r sine theta equals what? Y. All right, from here, I'm going to have to get the x's and the y's all on the same side and set them equal to 0. So I'm going to bring over the 3y. Sorry, I should have told y'all to write really tiny. So x squared plus y squared minus 3y equals 0. From here, this is the equation of a circle, obviously. It's not centered at the origin anymore. What I have to do to fix this one, because you're not going to see your answer like this, they're going to complete the square. And so I know that this is probably a section that you may have blocked out of your memory because it wasn't very fun, but we're going to complete the square here. And since I have two y values, that's what I'm completing the square with. Here, the x value of the center is going to be 0, but obviously the y is shifted a little bit. So when I complete the square, it's going to look like x squared plus, and we have a y shift. Going to look something like this. And inside this factor, the sign here is always going to match this sign. So if that's a minus, this one's also going to be a minus. And the formula to complete the square, this again is a blast from the past. The formula to complete the square is b divided by 2 squared. And so what's in parentheses goes in parentheses. So I know that my b value is this. So I've got the 3, and I ignore the sign because I already put the sign here. So I'm going to have 3 divided by 2, and that goes in parentheses. 3 divided by 2. And then on the other side, so anything you do to one side of the equation, you have to do to the other. And you always add. So over here, I am adding b divided by 2 squared. So I'm squaring this value is what technically I'm adding over here. So I have to square it. And that's why you always add, because when you square something, it doesn't matter if it's negative, it's still going to be positive once you square it. So I get 9 over 4. So I'm adding 9 over 4 onto this side. So now that is actually my equation. I just clean it up and rewrite it. So I get x squared plus y minus 3 halves squared equals 9/4. It's ugly, and that's okay. You can do it. This one is also ugly, just FYI. But I mean, it's doable. You don't need a calculator. And I wouldn't be surprised if OnRamps really likes to put one of those on your assessments. Again, I don't know what's on them, but this kind of ties into what you learned in the other unit where you had to do conic sections. So I would like for you guys to take some time to do the other 4 on your own, and then I would like to see some answers up on the board. If you want to write all your steps, you can. If you want to write your answers, you can. But it might take you a minute. So maybe 10 to 15 minutes for us to get these 4 up on the board.